Welcome to the new chapter, Transformation Techniques and Feature Selection. Till now we have seen how to handle data in the MATLAB and how to make data clean for modeling. After getting a clean data, we have to follow certain steps and that would provide better predictions. Transformation and feature selection, both techniques are powerful technique and used for increasing accuracy of model. Both techniques we can apply at the beginning before going for machine learning modeling, or we can apply as a retuning depending upon user requirement or type of data. Retuning means, suppose we have made algorithm having accuracy 70% and we are not satisfied with 70% accuracy, then we can retune our model to increase accuracy. So transformation and feature selection plays an important role to increase efficiency of model. In this chapter we are going to see different techniques of transformation and feature selection. At the end of this chapter you are able to understand what is the use of transformation and which transformation is right transformation depending upon type of data. And second point is how we can select appropriate feature and different ways of feature selection. In this video we are going to see information about transformation, so let us start. We have already discussed type of data distribution. If data is normally distributed, it will provide optimized model. But in the real world, hardly you will get normally distributed data. So is there any way to make data normal? Yes, with the help of transformation techniques, we can get data points which shows close behavior like normal distribution. If our data is skewed and has a huge pickedness, we have to use such transformation which can compress data. Square root, cube root, log and reciprocal are the example of compression techniques. Each technique has its own advantages and disadvantages. And if data is skewed and it is already compressed, we can make data normal by taking square and cube transformation. Over here you can see data distribution is positively skewed and data has a huge pickedness. To make it normal, we have to compress each and every observation. To compress dataset, we can use square root, cube root, log and reciprocal transformation techniques. At the end of video, we will note advantages and disadvantages of these transformation techniques. This is all about if data distribution is positively skewed and has huge pickedness. But what if data is already compressed? Over here you can see data is already compressed and negatively skewed. To make it normal, we have to apply square or cube transformation or any other higher power transformation. Let us visualize the same thing in the MATLAB. We have already done analysis on MBA dataset and we are familiar with dataset. In the previous chapter, we have found that Workx feature is positively skewed and GMAT feature is negatively skewed. Let us see the histogram of Workx feature. You can note data is positively skewed. Same thing we can validate with the help of boxplot and skewness function. If we check skewness value, then yes, we can say skewness value is positive. So data is positively skewed. And we have already discussed if skewness value is equal to 0, then data follow normal distribution. So to reduce skewness value, we have to apply transformation techniques. Over here you can see the code. I have used log, square root, cube root and reciprocal transformation. And if I check histogram of each technique, we are able to conclude which transformation is perfect for Workx feature. We can also conclude by checking skewness value of each technique. Whenever we find skewness value is close to 0, we can say that particular technique is perfect for that particular feature. Now check the histogram. Over here you can clearly see difference between positively skewed data and transformation techniques. You can conclude data is compressed and for Workx feature cube root transformation is showing distribution close to normal distribution. And at the end we can say cube root transformation is good to go ahead for the modeling. Now if we check histogram and skewness value of GMAT feature, then we can conclude GMAT feature is negatively skewed and assume this time data is compressed. To make it normal, apply square and any higher order transformation. And if we check the histogram, we can conclude cube transformation is close to normal distribution. So for future operation, use the dataset which shows behavior close to normal distribution. Over here you can note some important points. First point is, if data has high pickedness and it is skewed, then compress that data, and to compress use square root, cube root, log and reciprocal transformation. Also note these points. First one is, cube root transformation is more powerful than square root transformation. Second point is log transformation and reciprocal transformation are more powerful techniques than cube root transformation. Third point is square root transformation is not applicable to negative values. Fourth point is log transformation is only applicable to positive values. Fifth point is reciprocal transformation is also not applicable to zero values. The second note is if data is already compressed and it is skewed, then to make it close to normal distribution, use square, cube or any higher order transformation. Obviously, more the power, it would more powerful. To get more information about data transformation techniques, watch our best transformation techniques for machine learning from Fun with MATLAB series. This will end our video. In this video, we have seen different techniques of transformation. In the next video, we are going to see how we can select appropriate feature for modeling. Thank you for watching this video. Do like this video if you found it helpful. If you have any queries, post them in the comments and get in touch with us. Follow us on LinkedIn, Facebook and subscribe to our YouTube channel. Education is our future, MATLAB is our feature. Happy MATLABing.